Alright, y'all, go ahead and turn to, in your Chapter 1 packets, to Lesson 1.5, Inverse Functions. This should be after your Exploring Inverse Functions activity worksheet that we've been working on. And I'm going to work through one of the problems, kind of all the way down as kind of a demonstration, so you can kind of see what we're looking for when solving the other problems. So I'm going to work f of x is equal to x squared minus 3. It asks us to plot the points, or to graph the function by plotting specific points. I'm just going to go and use the range from -2 to -1. And I'll get these computations done real quickly. That's what you'll get. So that's ultimately what you'll get. Again, plug a -2 in, you'll get a 1. 0 squared is 0, minus 3 gives you, -0, my bad. It's supposed to be a -0. Then if we plot that, you get something that looks kind of like that. I know it's not the prettiest looking graph. My device here is not the friendliest. Alright, now it asks us to swap our x and y values out. I'm going to erase that. And if at any point that you need to pause the video or rewind it to kind of get something reclarified, or to just make sure you're caught up, by all means go for that. But again, swapping out our x and y values, we get 1, -2. Basically, I'm just taking these values right here and just swapping them, and same for basically the ones on the bottom here. Get -2, -1, -3, 0, -2, 1, and then 1, 2. Let's plot it on the graph. -3, 0. Graph's right here. It looks something like this. Now I'm drawing a dotted line. This is a very crude dotted line of the line y equals x. Now the reason I'm doing that is because I want to show that whenever you are taking your inverse, in case this blue function is our inverse, it is a reflection across the line y equals x. So it's basically taking our original function here and just kind of reflecting the graph over the line y equals x. It's kind of like a diagonal kind of axis. Another thing that we can notice is that our inverse is technically not a function. If you do the vertical line test, as you can see here, it will pass through 2 points, essentially all the way through the graph, with the exception probably being this way endpoint right here. Because of that, our inverse is not a function. We have a new definition for our functions. We can say that our original function, x squared minus 3, is not 1, 2, 1. And we'll get into what 1 to 1 means later, but kind of for this, what you need to know is that if a function and its inverse are both, if a function's inverse is indeed a function, then that function is 1 to 1. If a function's inverse is not a function, it doesn't pass the vertical line test, or it has repeating x values, then it would not be 1 to 1. I'm going to roll down here. Again, if you need to pause the video at any point to catch up, rewind it at any point to catch up, that is okay. Now we're going to determine what the equation of our inverse would be. And the way that we would do that, again, if we do our y notation, y equals x squared minus 3, what we would get is what we would do is kind of the same concept that we did on the top. We would swap out our x and our y values, so that we would get x equals y squared minus 3. Basically, this y would move over here, and then this x would kind of just move right there. From this, we can do x plus 3 is equal to y squared. Square root that, we will get the plus or minus x plus 3 is equal to y, and that is equal to, and this is also equal to the inverse function, which this f of -1 of x is basically our inverse notation. So now how can we determine or confirm whether or not our inverse function is indeed the inverse of that said function? If we hearken back to function composition, we can see that that will tell us whether or not our function is indeed an inverse or not. So let's do function composition here. So basically, if we compose inverse of f of x inside of inside of our original function, it should simplify out to be x. And then same concept, but kind of flip the functions. If you compose the original function inside of its inverse, or a supposed inverse, it should simplify out to be x. So let's try it out for this. F of inverse of x is equal to, well, our inverse of x is plus or minus square root of x plus 3. Plug that inside of x squared. That would just be this square root of x plus 3 squared. Minus 3, this simplifies down to just simply x plus 3 minus 3. And then that simplifies down to x. So we're on the right track so far. Then, if we compose our original function inside of our supposed inverse, again, our supposed invert, again, hypothetical because we're doing this to check to make sure it is the inverse. Plus or minus x plus 3, we plug in x squared minus 3 in, plus 3. These plus 3's will cancel out, and then we are left basically with the square root of x squared, which that is equal to x. So, yes, plus or minus the square root of x plus 3 is the inverse to x squared minus 3. So now that we've demonstrated one of the problems kind of all the way through the throughout basically graphing it, flipping the y and x values, graphing that, determining the equation, and then determining whether or not it actually is an inverse or not, you should be able to go now and complete the other two problems all the way through on that worksheet. Thank you.